In the late 19th century, electrical experimentation was still in its formative stages. Inventors explored different methods of generating, transmitting, and transforming energy. Among these figures was Nikola Tesla, whose work often focused on electrical systems that behaved differently from conventional designs. Over time, many interpretations of Tesla's work have circulated, especially those related to coils, resonance, and energy transfer. These interpretations have led to various modern adaptations, including instructional systems that claim to replicate or reinterpret aspects of his designs. One of these interpretations appears in what is referred to as the energy revolution system. The energy revolution system is presented as a digital instructional package. It does not consist of a physical device. Instead, it provides a set of documents that outline how to assemble a device using commonly available components. The package includes schematics, written instructions, and a list of materials. These materials are described as accessible through general hardware or electronic suppliers. At the center of the system is a configuration inspired by a bifilar coil design, historically associated with Nikola Tesla. The structure of the product focuses on explaining how to recreate a specific arrangement of electrical components. The product is not software-based. It is a set of instructions that leads to a physical outcome, depending on the user's execution. The usage process begins with accessing the documentation through an online portal. Once access is granted, the user is expected to review the materials in full. The first stage involves understanding the schematics and identifying all required components. These components must then be sourced independently. After gathering the materials, the user proceeds to the assembly phase. This involves manually constructing the device according to the provided diagrams and instructions. The process includes interpreting circuit layouts, connecting components, structuring the coil configuration, testing the assembled unit. The estimated build time is approximately 4 hours, depending on the user's familiarity with manual assembly tasks. Once assembled, the system is described as requiring minimal interaction. Aside from occasional inspection, this type of product aligns with individuals interested in hands-on construction and experimentation. It assumes a willingness to engage in a process that includes reading technical documentation and performing physical assembly. It may appeal to users who have an interest in alternative energy concepts, prefer building devices rather than purchasing finished products, are comfortable sourcing components independently, are open to experimenting with electrical setups. It does not appear to be designed for users seeking immediate, plug-and-play solutions. The outcome depends on execution, interpretation of instructions, and component selection. Compared to conventional energy systems such as grid electricity or solar panel installations, this product occupies a different category. It is not an infrastructure system, but an instructional framework. Unlike commercial energy solutions, it does not include installation services, certified hardware, or standardized performance metrics. Instead, it provides guidance for constructing a device independently. In comparison with other DIY systems, its structure is similar: documentation, schematics, and assembly instructions. The distinguishing element is its reference to historical electrical designs, particularly those associated with Tesla. As with most instructional products, the final outcome is not pre-built. It depends entirely on how the user follows and implements the provided material. For those interested in examining the original documentation and instructions, a link is available in the video description.